Question 47. The molar conductivity of solution of a weak acid HX, concentration is given as 0.01 m, is 10 times smaller than the molar conductivity of a solution of weak acid HY, whose concentration is given as 0.1 m. If limiting equivalent conductance of X minus ion is equal to limiting equivalent conductance of Y minus, the difference in their pKa values, that is pKa-HX minus pKa-HY is dash. Consider degree of dissociation of both acids to be smaller than 1. Let the concentration of HX be C1 and concentration of HY be C2. Degree of dissociation of HX be alpha 1 and degree of dissociation of HY be alpha 2. Now HX dissociates to form H plus and X minus ions. Now since the initial concentration of HX is C1 and degree of dissociation is alpha 1, the equilibrium concentration can be written as C1 1 minus alpha 1. Concentration of H plus is C1 alpha 1 and concentration of X minus will be C1 alpha 1. Therefore Ka for HX will be equal to C1 alpha 1 into C1 alpha 1 divided by C1 1 minus alpha 1. Now since the value of alpha is smaller than 1, it can be neglected in the denominator and KaHX will be equal to C1 alpha 1 square. Similarly, HY dissociates to form H plus and Y minus ions. And Ka for Hy will be equal to C2 alpha 2 square. Now according to the question, molar conductivity of Hx divided by molar conductivity of Hy is equal to 1 by 10. Now alpha 1 divided by alpha 2 will be equal to, the value of alpha 1 will be equal to molar conductivity of Hx divided by conductivity at infinite dilution of Hx, and alpha 2 will be equal to conductivity of Hy divided by conductivity at infinite dilution of Hy. Now since the limiting equivalent conductance of X minus and Y minus ions are same, therefore equivalent conductance at infinite dilution of Hx and Hy will also be same. Therefore alpha 1 by alpha 2 will be equal to molar conductivity of Hx divided by molar conductivity of Hy, and this is equal to 1 by 10. Now KaHx divided by KaHy will be equal to C1 alpha 1 square divided by C2 alpha 2 square, or this is also equal to C1 by C2 into alpha 1 by alpha 2 whole square. Now putting the value of C1 and C2 and alpha 1 by alpha 2, the value of C1 by C2 into alpha 1 by alpha 2 whole square will be equal to 0.01 divided by 0.1 into 1 by 10 whole square, and this is equal to 1 by 1000. Therefore KaHx divided by KaHy is equal to C1 by C2 alpha 1 by alpha 2 whole square, and this is equal to 1 by 1000. From this, log KaHx minus log KaHy will be equal to minus 3. Now pKaHx will be equal to minus log KaHx, and pKaHy will be equal to minus log KaHy. Therefore, pKaHx minus pKaHy will be equal to 3.